All right, this is section 9.3. We're multiplying and dividing signed numbers. And you need to know a couple of rules before we get started with this. The first one is the rules are both for multiplying and dividing signed numbers. And so the rules are this: if the signs are the same, the answer is always positive. And so an example of that would be -9 and -2 multiplied together. Both are negative, signs are the same. So the answer is a positive 18, because 9 times 2 is 18. I have a negative and a negative, meaning the signs are the same, so it makes a positive answer. The other rule is if the signs are different, the answer is always negative. So I have one negative and one positive number multiplied together. 8 times 4 is 32, and I have a negative answer because the signs are different. So -32 is the answer for this one. So for this lesson, I just have a bunch of problems, and we just need to go through each of the problems and look at them and decide what the rule is. I feel like these are very simple, but you have to keep them separate from how you multiply and divide versus how you find the rules for add and subtract. So a +6 times a -3, well, 6 times 3 is 18. The signs are different, so it's a negative. The next one is -5 times 11. Signs are different, so it's negative. 5 times 11 is 55. I have +12 and -7. Signs are different. The answer is negative. 12 times 7 is 84. Okay. The next one is a -7 and a -4. Well, their signs are the same, so the answer is positive. And notice I don't really have to put a plus sign, but I'm doing it to remind myself that is a positive answer. And 7 times 4 is 28, so 28 is my final answer. Same thing with the next one. They're both negative, so it gives me a positive answer. A -10 and a -5 gives me a positive 50. 10 times 5 is 50. Both signs are the same, so the answer is positive. The last one is 6 times 2 is 12. 2 negatives make a positive when you're multiplying and dividing. All right, a +7 and a +5, the signs are the same. The answer is positive. 7 times 5 is 35, so positive 35 is my answer. Oop, I didn't write the lines on these. No wonder they look funny, because they're supposed to be divide signs between each of them. All right, this next one is -15 over 5. Well, in a fraction, that bar means to divide. So these are division problems, every one of those. Obviously, except for the first one that we just multiplied. So -15 divided by 5, well, 5 goes into 15 3 times. The signs are different here, so it's a -3. Okay. This next one, division problem, which is going to actually be -75 divided by -25. Okay, so 25 goes into 75 how many times is what we're working on. Well, 25 goes into 75 3 times. The signs are the same, so it is a +3. Okay. The next one is a -6 divided by 0. What happens when we have a problem that's like this? Well, remember that when you are dealing with fractions, for this guy, well, this is a bad example. Let me go back to the one we just were talking about. It means that when I'm drawing a picture with how many pieces, it means that there are no pieces. If there are no pieces to even discuss, it means there is no picture. So that means that this problem is undefined because the denominator cannot be 0 when we have a fraction or a division problem that's set up like a fraction. So it doesn't matter if it's positive or negative. If the denominator or the bottom number is 0, the answer is undefined. The 90 divided by -9, the signs are different, so the answer is negative. 9 goes into 90 10 times, so -10. All right, this one got a whole page of its own just because it's going to take us a little bit of work to get it separated out. Well, what are we looking at? We're looking at a fraction divided by a fraction. So let's write this out to make it a little more clear here. I see a -2/3 divided by a -5/9. When we're dividing fractions, we are going to keep it the same, change it to multiply, and flip it over. Okay, we're going to divide by 3. in this diagonal, and 3 goes into 9 3 times, and 3 goes into 3 1 time. Notice I circle what I have left over, so when I'm multiplying this, I have a negative 2 times 3 over a 1 times negative 5. Okay. Also notice that this original problem up here in the top left corner possibly looked like this with a negative sign out beside both of them, but notice that I gave that negative sign to the numerator when I started working this, so I knew where it went. Okay. Have to attach it to a number when I start flipping things over and rearranging them. It could have went to both in the denominator. It could have went one numerator, one denominator. It doesn't matter as long as that negative stays in this problem, either top or bottom, and that negative stays in that problem, top or bottom. So what I did was I gave it to the 2 and I gave it to the 5, which were both the numerators of both of those pieces. So now here it is, that 2 has a negative, the 5 has a negative, and it's carrying on to the end. If I kept them out perfectly to the middle, I don't know if I would have paid attention to them as well or kept up with them as well. So anyways, here I am at the end. And I have negative 2 times 3, which is negative 6, right? Signs are different. Multiply, and the answer is always negative, so I got negative 6. In the denominator, I have 1 times 5 is 5. Signs are different, so the answer is negative. But now what I have is a fraction, which is actually a division problem, and both of the signs are negative. So if the signs are the same, the answer is actually positive, so this simplifies to be 6/5, positive 6/5. Final answer.